All right, this lesson will involve us looking at some linear inequalities. An inequality means it doesn't have an equal sign in it. It has some form of a greater than or less than symbol in it. It might be greater than or equal to, or less than or equal to, or whatever, but it has some form of inequality symbol in it versus an equals symbol. We're actually going to come back and fill this in after we've done a couple of examples because I want you to see if you can come up with some patterns on your own. So here is a linear inequality, not an equation, because it has a greater than or equal to symbol in it. I can tell that this is a line because it has both an x and a y in it, and none of them are squared. They're just an x and a y. And I can get this into y equals mx plus b form, and then you'll be able to tell a little bit easier that it is a line, and that's what we're going to do to start out with. We're going to get this into y equals mx plus b form, which is most familiar to you. Okay? So to do that, we are going to subtract 2x. We're going to treat this exactly like it was an equal sign. The only exception is when you have inequality symbols in there, when you multiply or divide by a negative, you have to switch the direction of the inequality. Right now we're subtracting, so we don't need to worry about that. So I will cross those off, and I will have negative 3y is greater than or equal to negative 2x plus 6. Did not need to switch it because I was subtracting. Now to solve for y or get y by itself, I would need to divide by negative 3. And because I am dividing by a negative, I do need to switch the direction of the inequality symbol. So that leaves me with y is less than or equal to, and a negative divided by a negative is a positive 2/3 x, and then 6 divided by negative 3 is negative 2. So here is our function in y equals mx plus b form, which hopefully you can see better now is a line. Okay, so we're going to go ahead and graph that. We can see that the y-intercept is negative 2. So it's going to cross the y-axis at negative 2, and that the slope is 2/3, so it's positive. And from that y-intercept dot, if my slope is positive 2/3, remember slope is rise over run, so I will go up 2 and right 3, or I could go down 2 and left 3. Okay, and then I need to connect those dots. And when you have inequality symbols, you need to decide whether you're going to connect the dots with solid or dotted lines. And when it's underlined like this one is, then you will connect it with solid lines. If it's not underlined, you will connect it with dotted lines. So I always think a solid line here has to mean a solid line here. Okay, so I'm going to connect those dots with a solid line. Again, if it was not underlined, that black line would be a dotted line. And now with inequality symbols, you have to shade, and you have to decide which direction to shade. So what I'm going to have you do is pick a point on either side of that line. And the easiest point, if you can pick, is to pick 0, 0. So I'm going to pick this point right here. And I have to decide if that is a solution to this inequality or not. If it is, then I will shade on that side of the line. And if it isn't, then I won't shade on that side of the line. So I am going to plug, and this is 0, 0. So I am going to plug 0 in for x and 0 in for y and decide if I have a true statement or not. So is 0 less than or equal to 2/3 times 0 minus 2? Or is 0 less than or equal to 0 minus 2? Or is 0 less than or equal to negative 2? And 0 is not less than or equal to negative 2. So I will not shade on that side of the line. I will shade on the other side of the line. Okay? What I want you to notice too is that I got this into y equals mx plus b form. And notice how this was a less than symbol once it was in y equals mx plus b form. And I shaded below the line or underneath the line. Okay, here's another one. This is a special kind of a line. It only has an x in it, not an x and a y, but it is a line. I can subtract 2, and I do not need to switch the direction of the inequality when I subtract, only when I multiply or divide by a negative. So this is what my line should come out to look like. Okay, it only has an x in it, and so if it was an equal sign in there, it would be x equals -2. That means all your x values are held constant at -2, which would be, you know, here, I don't really care what my y is. My x is -2, my y is 6. Here, my y is 2, but my x is -2. Here, my y is -3, but my x is -2. There's no y in this equation, so I don't really care what my y values are as long as my x values are held constant at -2. Again, because this is underlined, I will make this, connect these dots with a solid line. Okay, and then I need to decide which direction to shade. So again, I'm going to plug a point in. This is the point 0, 0, which means x equals 0 and y equals 0. I don't have a y in the equation, but I do have an x, so I'm going to plug that in, and this is what I have to decide. Is 0, which I'm replacing for x, is 0 greater than or equal to -2? And yes, it is. So I will shade that direction, okay? I also want you to notice kind of the direction of the inequality here. Notice x is greater than or equal to -2. You're going to shade all the spots that are bigger than, which do point to the right, and the arrow points to the right. Okay. And one more really quickly. We're going to get this one into y equals mx plus b also, which means that I want the y on the right hand or on the left hand side. So I will add the y over, and I will have y plus 3 is greater than 4. Subtract 3. So I have y is greater than 1. Okay, again, this is a line. It's a horizontal line this time. I don't really care what my x values are. There are no x values in the equation, so x can be anything you want, but your y value has to be held constant at 1. So no matter what your x is, your y value has to be 1. This inequality symbol right here is not underlined, so you're going to connect those points with a dotted line, and then you need to decide where to shade. Okay, and so I either need to shade above or below the line. Again, I'm going to pick 0, 0 because it's really easy. I don't have an x coordinate to plug anything into, but I do know that my y is 0. So my question is 0 greater than 1? That's what I have to decide. And 0 is not greater than 1, so that is not a true statement, which means I won't shade on that side of the line. I don't need that there. Instead, I will shade above the line, okay? And I want you to notice that this equation is in y equals mx plus b form. It was a greater than symbol in here, and I shaded above the line, okay? So now that we've kind of looked at ways that you can do that, I will give you a couple of shortcuts. If anybody kind of has noticed a pattern, you're probably right, so I do want to talk about that with you, okay? When you graph inequalities, you do want to switch the direction of the sign when you multiply or divide by a negative. You're going to shade above the line if it's a greater than or equal to symbol or a greater than symbol. Once you get into y equals mx plus b, it has to be in y equals mx plus b first for you to decide. Okay, and you'll shade below the line if it's less than symbols. And then you'll do dotted lines if it's not underlined. And you'll do solid lines if it is underlined. Okay, and that should be this lesson.